Good evening, I am Michael Davidson and I am presenting my honors contract project for ITSY 2300 Operating System Security, and the title of my project is The History and Development of Cryptography. In fact, what is cryptography? It is known as the science of sending secret messages used to prevent interception of messages sent across a network. Dates back to ancient civilizations like the Egyptians, and the word is derived from the Greek kryptos, meaning hidden. Cryptography has developed through the course of history, developed through process, and is applied to modern-day operating systems like Unix, Linux, Windows Server 2008, and Windows 7. Let's talk about the history. Before I get into the history, let's talk a little bit about the process. Encryption is the process of translating a plain text message into a secret message, while decryption is the process of converting a secret message back to its original plain text form. Now let's talk about the Egyptians. They developed a system called hieroglyphics, which are pictures that are used that they were to communicate messages back and forth to each other, because back then there was no writing system developed, so they just used pictures of different objects to communicate. And these pictures are also known as hieroglyphics, like you see at the bottom of the screen. And let's talk more about the ancient civilizations. The Assyrians developed the intaglio, which was a device that they used to introduce themselves when conducting transactions. They used a flat stone that was carved into small images. The method developed in 1500 BC. The trader used the device so no one will not be able to use his signature. This method paved the way to what we call the digital signature. The Atbash cipher was developed by the Hebrews around 500 to 600 BC. They used a simple alphabetic substitution. Substitutes the first letter of the alphabet with the last letter, and they also substitute the second to the last letter with the second letter in the alphabet, and it goes so on and so forth, like A being Z, B being Y, and C being X. The Spartans developed the first military-based cryptographic system. They invented the skytile, which is made of the following: strip of paper, a wood staff, and a leather or parchment paper. There's an example right there at the screen showing how they were able to use this device to send out secret messages. Let's now talk about Julius Caesar. He developed a substitution cipher which involved the shifting the letters by 3. So if you were to use the English alphabet, he would use A would then become C, then B would become D. And he used this to communicate messages to his government officials. And he was also known as one of the greatest cryptographers in history. And there's another method that was developed by a Greek historian named Polybius, the Polybius square, like you see at the bottom of the screen. It dates back to the 2nd century BC, and right there he used a 5 by 5 square. Let's now move into frequency analysis. The concept was developed by Al-Kindi in 9th century CE. He believed that knowing the language was the best way to decrypt the encrypted language. The texts were compared to a language with the encrypted version of it. It also involved calculating percentages of letters of a particular language in plain text, calculating percentages in the cipher, and substituting the symbols for the letters who have an equal percentage of occurrence. In 1467, Alberti came up with the concept of the polyalphabetic cipher, which is difficult to break using frequency analysis. It uses a set of 2 metal discs containing letters and numbers. Like you have a set here, and then in the outside, and also one in the middle. And it's also, they use that to communicate messages secretly. More about the polyalphabetic cipher. Similar to substitution, used a 1-to-1 and many 2-1 ratio of plain text. Different corresponding characters at different locations in plain text. Another cipher developed by Blaise de Vigneron. The Vigneron cipher was developed in the 16th century under King Henry III of France. And the Vineyard cipher is a table used in a combination of keyword or phrase, closely resembles Caesar method, uses a table where every row shifts by one, as you see at the bottom of the screen. During the course of World War I, the Germans got a message that was intercepted by the British, and this caused them to develop a machine that would have secret messages, cryptographic messages that would be hard to break. This machine is known as the Enigma machine, and it improved the confidentiality of secret messages, and it was invented in 1918. The machine used several rotors which changed character positions after each message. And here's a picture on the next slide. You have got your keyboard right there, and then your rotors. And each time a button is pressed, the rotors will then change the position of each character, making it hard for someone to break it. Now let's move into this guy named Dr. Claude Shannon. He received a PhD in 1941 in mathematics. He worked on cryptography projects during the course of World War II, started working for Bell Labs, and he also developed what we know as information theory, and proved that unbreakable cryptography was possible through some of his rhetoric. Now let's talk about some of the standards that are used as of today. The data encryption standard, it was developed by IBM in 1977. It used a 56 key or 6 bits of blocks of data, involved 16 rounds of operation. Later evolved to 3DS or triple data encryption standard, and DES software is prohibited for exportation in the United States. Diffie and Hellman developed a crypto system that involved public keys. Each user on one end of the network will have a public key and instead of private key. They came up with the idea on how to correct key management problems in a crypto system. RSA was named after three workers, Rivas, Tremere, and Altman. They patented it in 1983. It used a set of large prime numbers, and the next thing that happens is the variables are assigned in this equation: n equals p times q. Then numbers are chosen, e is less than n. Then d is determined, divided by prime factor assigned to p minus 1 times q minus 1. E and d make up the public and private components. N and E are the public pair, while N and D make up the private pair. Advanced Encryption Standard. It replaced DES, developed late 2000 and 2001, also known as the Rijndael algorithm, founded by 2 Belgian cryptographers. It also used 128-bit blocks of data, which is better than what DES was using, only 56 bits. And it supports 128, 192, and 256-bit keys. Now let's talk about, since we talked about the history of cryptography, let's go into the process of it. The first thing that happens is the writer writes a message in plain text, and then the plain text is then converted into an algorithm of the sender's choice. Then the message is encrypted, and then the recipient will, on the other end, will have a key or a password to use to convert the encrypted message into the original message, and this process here is repeated for a reply. However, a secret message has the possibility of getting intercepted. At times, a man-in-the-middle attack is used to intercept an encrypted message. The attacker could read the message and not take any action and send it to the intended recipient, or he could change the message, like saying "you're hired" to "you're fired," and sending the changed message to the intended recipient, which could also deceive the one that received the message. Now let's talk about applying cryptography in Windows Server 2008. It comes with Cryptography Next Generation. It allows users to create, update, or change algorithms. It's used in Windows Server 2008 features like Active Directory Certificate Service, Secure Socket Layer, and Internet Protocol Security. and Windows Server 2008 also uses BitLocker drive encryption.